Hello, today in this lesson we are looking at the characteristics of the normal distribution. What in the world do I mean by that? We're also going to break that down into, we're going to use the empirical rule for 1, 2, and 3 standard deviations for a normal distribution to determine percentages of data, and we're also going to use the experimental or empirical rule for 1, 2, and 3 standard deviations for a normal distribution to determine numbers of data. What in the world do I mean by that? Okay, I will likely break this lesson down into at least 2 different parts. So we're going to start off with U2B1 here, just looking at the characteristics of a normal distribution. Okay, normal curve. Many common statistics such as human weight, human height, or blood pressure gathered from samples in the natural world. Okay? So many common statistics gathered from samples in the natural world. I mean, this is just natural. It just happens naturally. Tend to have what's known as a normal distribution about their mean. What do I mean? Let me give you an example. Let's take the ACT. Okay? Raise your hand if you've taken the ACT yet. Okay? A few in this class have taken it. And hopefully towards the end of this year, you will, as a junior in high school, no, many of you, most of you are juniors, right? Raise your hand. Junior? Okay, yeah. So really, I would recommend that you plan on taking the ACT June, maybe before, but I would suggest that we finish this class, that you finish Algebra 2.
My next one is February, in February. I think we all have.
Okay, so we're going to take the example of the ACT. Let's say across the state of Tennessee, we have all the juniors taking the ACT. Now, I don't know how many students that is. I'm gonna say 5,000. I mean, maybe that's overestimate. Maybe it's only 2,000 or 3,000. But I bet there's quite a few. Right? So they're all going to take the ACT. Let's suppose there's 5,000 students that take the ACT. Now, the results from the ACT, you're going to have, are you going to have just like everybody acing it, making a perfect score of 36? Of course not. Is everyone going to just bomb the ACT? Is everyone going to make, I don't even know what the lowest score in the ACT is.
I got a 15. I don't know if it can get worse than that.
You might be right. Congratulations.
Yeah.
Okay. So let's try not calling our friends out on this one.
I thought I did, man.
Wow, that's embarrassing.
How do we get a 10?
Okay, so I don't know what the lowest score that you can actually get on the ACT is. However, is everyone, all 5,000 students across the state, going to make the lowest score? No. As it turns out, you've got the lowest score, you've got the highest score, and somewhere in the middle, you typically find a great majority of people making kind of like all the scores kind of pile up. So like you have a whole bunch of people say make, I don't know what the average is. Let's say it's 23. Okay, so you could have maybe a score of a 23 here, and a score of let's say a 36 here, and let's say, I guess, a score of 10 here, if that's possible. All right? So as it turns out, there's a whole bunch of people that made a 23 on this test, which is not bad. Very few made a 36, very few made a 10. But you see how the grades will kind of make this curve. Like if you piled up the number of people that made 23s, the number of people that made 22s, the number of people that made 21s, the number of people that made 20s, and likewise 24s, 25s, 26s, and so forth. It typically makes this normal curve. Now, if anybody has ever heard of the bell curve, raise your hand if you've ever heard of the bell curve. I see a few hands. Well, the normal curve and the bell curve are the same. It's the same thing, it's just a different word for it. Why is it called a bell curve? Well, my grandmother, her name was Mama B. Her name was Beatrice, so Mama B. That shape, she used to collect bells everywhere she'd go. So that little shape right there, it's like one of those little handbells that you hold. Okay? So that's the shape, the bell curve. And this is what it looks like. A couple things that I need to define for you. This Greek letter, we say mu, is known as the, you want these notes, so go ahead and jot these down. Mu is the average, it's the mean of the data. This symbol here, also a Greek letter, it is the letter sigma. It is the standard deviation. We'll say away from the mean. It's the standard deviation. This right here is the mean. Okay? So here's how this works. Let's suppose we all take a test. Just a normal test out of 100, you know. You guys, let's say the average, let's say the mean was 85. Now, did everyone make an 85? No. You made a 90. You made a 92. She's got it. Oh, poor Logan. Poor Logan. You made a 70. All right, you made a 75. All right, you made a, we'll say an 82. I know, he's the smartest kid in the class. And he's also got the biggest hair. Okay, now do you guys remember the scores that I gave you? Okay, do you remember each? Okay, so what was the class mean? What was the average? What did I say it was? 85. Now, okay, what was your score? A 90. How many points away from 85 was that? 5. Okay. What was your score? A 92. A 92 is 7 points away from 85. And what? 70. Oh my, that was 15 points away from the 85. You guys understand what I'm doing here? Taking each person's score and I'm measuring the distance away from the mean. Does this make sense? Now, so how far away from the class average were you?
5.
And how many away from the class average were you? 7. And how many away were you? 15. Okay. So if you do that for each person, now, by the way, I could find the average distance away from the average. Follow me on that. You were 5, you were 7, and you were 15 away. Right? 3 different people, 5, 7, and 15 away. If I was just to take those 3 and I added those numbers up, 5 plus 7 plus 15, what's that? That's 27. Now 27, in this case there's 3 people there, so if I divide by 3, 9, of course. Now that is their average score. Let's see, how do I say this? That is the average. So, on average, these 3 people made how many points away from the class average? Does this make sense? Raise your hand if that makes sense to you. I have 3 people. They didn't make the class average. They made something some more or less. I took however much away. I measured their score and the distance away from the mean. I measured that, I added them together, and in this case I divided by 3, and so I got this number. Now, this number is very, very, very similar to this number called sigma, the average distance away from the mean. Okay? Okay, so this curve, you need to be able to draw it, to understand it, to know what it all means. Let me go back to this right here. Now, in our example, 9 units away, if the class average was an 85, and if the standard deviation for the class was a 9, then 85 plus 9 is 94, right? What's 85 minus 9?
Or 76.
76. Now, what's 94 plus another 9?
103.
103. And what's 103 plus another 9? 112. Now, 76 take away 9? 67, yes, 67. And take away another 9? 58. Now, in our example, if the class average was an 85 and the standard deviation was 9, then here's what's interesting. These percentages hold true for every single normal distribution in the world. 68%, don't miss this, 68% of the people that took the test made a score from 76 to a 94. 68%, just a little above 2/3 of the class made somewhere between a 76 and a 94. Now, get this. 95% of the class made between a 67 and 103. 99.7 made between a 58 and 112 on this test. Now, what about the other 0.3? Well, there's situations where we have people that make scores below 58 or 112 in this case. Now, here's the deal. Everybody look at me on this. Our example of a test and the average being 85 and the standard deviation is just one of an infinite number of examples that we could create that follow these rules. Now, we're going to look more details in the next lesson on how to calculate exactly how many students made, let's say, between a 76 and an 85, or between a 94 and a 103, or whatever. There's a couple rules that I'm going to introduce to you in the very next lesson. So, the only thing that I would ask you to do now is see if you, well, no, I'll tell you what, I'm just going to ask you to wait to the next lesson. You can go on to the next lesson and get the rest of these details. Thank you for hanging in there.